everybody, it's Miss Austin. I'm going to be doing the lesson 4 practice problems. Number 1, match each statement using only the information shown in the pairs of congruent triangles. So number 1, it says in the two triangles there are 3 pairs of congruent sides. So if you look at this one, that's 1 pair, 2 pairs, that's an angle. They didn't tell us about this. Here, there's no sides marked, but they do share this one side. That's only one side. This one down here, we have 1 pair of sides, 2 pairs of sides, and then that piece right there, it's part of both triangles. So there's your third side. So this third drawing has 3 pairs of congruent sides. All right. So this is for number 3. The 2 sides and the included angle are congruent to 2 sides and the included angle. Included angle, I always say, is like an alligator inside of its mouth. So see how there's 2 sides, and do you see how the angle, I'll get a highlighter. See how the angle is in between the 2 sides? That's called the included angle. So this one goes to this. And then this one, even though we know it's the answer, let's make sure we understand what it is. 2 angles in the included side. See how you have 1 angle, 2 angle, and then they share this side. Angle, side, angle, angle, side, angle. So this one is number 2. All right, sketch the unique triangles that can be made with angle measures 40 and 100 and side length 3. How do you know you've sketched all possibilities? Well, first of all, I know a triangle adds up to 180. So if I have 140, the only other possibility, I got 40. So now, if 2 of the angles are the same, I know it's an isosceles triangle because the angles across from the sides are also going to be congruent. So I might have, and it says a side length of 3. So maybe, and I didn't really draw this to scale, but if this is the 100, and these are both 40, and then that would mean, I could have the 3 be here and here, right? That fits. But I could also have, and then this side would have to be much bigger, but then I could have a smaller version of this, because this could be 3. These would still be 40. Probably put the degree symbols on this. This is 100. And then these are something else, smaller. How do you know you've sketched all possibilities? Well, because it's an isosceles, it's either got to be these 2 sides are 3 or this base is 3. I guess I should probably write that in words. The triangle is isosceles. The base can be 3, like this drawing, or the legs can be 3. There's no other possibilities for the angles. All right, number 3. What is the least amount of information that you need to construct a triangle that is congruent to this one? So we did a lot of this today, and there's lots of choices that I could give you here. I'm just going to pick 2 sides in the angle. So if I gave you the length of this side and this angle, that would be enough to guarantee that you would construct a triangle that was congruent. So if I gave you the length of, and you could say the length of any 2 sides and the included angle, right? Maybe, I'm giving you a specific example. Maybe the length of LK and LJ and angle L. But basically, if I can give you 2 sides and the included angle, that's the one right in between. Number 4, triangle ABC is congruent to triangle EDF. So Maya knows that there's a sequence of rigid motions that takes ABC to EDF. I'm going to write that a little bit bigger over here. So I know those two are congruent because a rigid motion goes from here to here. Select all true statements. Angle A coincides with E. Look, first position, first position. Yes. B coincides with F. Second, AB, that's the first two, coincides with EF. No, EF is the first and the last. BC, that's the last two, coincides with DF. Yes. Segment AC coincides with ED. No. But also trace if you would rather. All right. We're skipping number 5. Number 6. Line EF is a line of symmetry for figure ABECDF. ABECDF. Claire says that ABEF is congruent to CD. Where's F? I can't see. FE. Because AB and CD are corresponding. Now, those two sides are congruent. I mean, they do correspond to each other, but she's not saying them correctly. If she's going to call this side AB, and this was reflection, she needs to call that side CD. Wait, which way did she go? A, B, E, F. And what did Claire say? Oh, yeah. She needs to say, sorry, if she says AB, she needs to say DC, and she said CD. She's not using the corresponding parts. You could say the letters are not in the right order. She's not using corresponding points. Write a correct statement. So I'm going to use hers. She says ABEF is congruent to, if she went like this, AB, look over here, I'm going to go DCEF. DC. Triangle HEF is the image of triangle HGF after a reflection across line FH. So I'm going to write that out. My choices are on the other page here when I printed it out. I don't know if it's like that in your book. So I'm going to move it so I can look at the picture at the same time. Forward this. Triangle, I'm going to write it here. HEF is congruent to HGF. Triangle FGH is congruent to FEH. You're just going reverse order on both. Yes. EFH is congruent to GFH. Yes. HFE is congruent to FHG. No, because they started with H. They'd have to start with H on this one. Angle EFG. I'm going to use the figure now. EFG. That's this huge angle right here. Is congruent to angle EHG. No, because the reflection wasn't that way. Segment EH is congruent to FG. No, you could also look at the letters. EH, wrong order. Segment GH, that's this one, is congruent to EH. Yes. Number 8. When rectangle ABCD is reflected across line EF, the result is BADC. How do you know that segment AD is congruent to segment BC? Well, these two triangles are congruent because a rigid motion took one to the other. So I automatically know they're congruent, and I know that the corresponding parts of those two triangles are congruent. Corresponding parts of congruent figures are congruent. Last one. This design from the construction of a regular hexagon. Began from the design of a regular. This design began from the construction of a regular hexagon. Describe a rigid motion that would take the figure onto itself. I'm not sure where you think you might try. You might try a reflection down the middle like this. But those small triangles, whoops, sorry, you can't see it, are in the wrong spot. You could try a reflection this way. Again, the triangles are in the wrong spot. So maybe we could rotate, right? Remember to find we'll just estimate the center of the hexagon. Yes. So rotation of 180 degrees around the center of the hexagon. And if I wanted to find the center, I could do a better job. I could have went like this, and like this. There, that's a better job. Now watch 180. Here's 90. There's 180. Still not the greatest job. But you can see that these line up. So 180 degree rotation, doesn't matter which way. Whoops, 180 degree rotation around the center of the hexagon. All right, guys, I hope that helped. I'll see you soon.